Hello, welcome to the second part of two parts on binomial expansion. In the first part, we talked a little bit about using patterns in Pascal's triangle to expand binomials. In this part, we'll talk about using the binomial theorem. Alright, let's go to an example. Like if we were challenged to expand this binomial, we could do it the old-fashioned way. Alright, and we would just multiply it all out. Maybe one binomial at a time until we would get some sort of answer. And in the previous video we used Pascal's triangle, so what we could do is we could take the fourth row, 0, 1, 2, 3, 4, so the fourth row we could write the coefficients down. So 1, 4, 6, put spaces between them, and then we would take this first term and we would write it to the fourth power here and then count it down. We take the second term, including the negative sign, and we would start off with the 0 power and count our way up. We would add plus signs in between each of the terms, simplify, and we would get something like this. And so that works very nicely. What if, though, we got something like to the 15th power? Well, this becomes a lot more challenging because even generating Pascal's triangle down to the 15th row becomes a little bit tedious. So we have the binomial theorem that helps us expand something to a higher power that's a little bit more easy. And here's what the binomial theorem looks like. You can study this a little bit more. I'm going to move on into talking about the coefficients. We use Pascal's triangle to generate the coefficients, and in this case what we're going to do is we're going to use this this notation here to generate the coefficients. But before we talk about the coefficients, let's talk a little bit about this notation. So if I put brackets like this, 6, 2, it's also written like this in some books, in some places. So 6 combination 2, 6 choose 2. And the way we calculate this is we take this first number, put in the numerator, factorial, which means 6 multiplied all the way down to its root. So 6 times 5 times 4 times 3 times 2 times 1. All right. 2 factorial times 4 factorial looks like this. We could do some simplifying here. We can cancel out. If we had to do this by hand, these cancel out. So what we're really doing is we're looking at 30 divided by 2, which is 15. All right. You can also do this with your calculator. There is a factorial button, and it's a little hard to find. You have to go to the math. There's a math button on your calculator, and then there's different menus. You would go to the PRB, the probability menu, and then you will see the factorial button. But what might be easier is if you find under that same menu of probability, there's the NCR button here, all right, the combination button. And what you can do is to calculate this, you would type in, from your home menu, you would type in 6 first, and then you would type in NCR, and then you would type in 2, and then hit enter, and then you would get 15. So go ahead and try that now. To find the nth term of a binomial expansion, and this is a particular challenge that you will see for applications for the binomial theorem. So let's go ahead and try it. So first of all, if I want to find the 7th term of a binomial, what I'm really doing is I'm trying to find the coefficient is going to be found with 14/6. Why 14? Well, because it's the 14th power of the binomial, so that's easy. Why 6 though? Well, if we remember that the 7th term, when we count terms, we count the first, second, third term of a binomial expansion, but the power, this is really the power of the second portion of the term. And if you remember, the second portion starts to the 0 power. So as it turns out, in the 7th term, this portion is going to be to the 6th power. So I think you'll just have to remember that the coefficient is found with the power of the binomial, and then this is always going to be one less than the term that you're looking for. Once you get your head wrapped around how to find r, or what r means, r being the power of the second term of the binomial in the expansion, the rest of it is pretty easy. So if we go to the formula, there's a formula that says you take, after you find the coefficient, you write this as your coefficient, then you take the first term. The first term is always going to be these two numbers subtracted from each other, and then the second term here is always going to be to the power of r. Okay, so that's the formula. So once we substitute into the formula, we crank out the answer and we get something that looks like this. Don't be surprised to start seeing some really large numbers for coefficients here, because we're dealing with really large powers. Alright, let's try another example. Let's find the 10th term of this binomial. Alright, you should press pause and try this on your own. I will move forward and show the answer. So again, the coefficient will be found by, well, the top number is always going to match with the binomial. This number is always going to be one less than my term. They say find the 10th term. Alright, so that's going to be the coefficient. And then you take the first term here, you raise it to the power of those two subtracted by each other. You take the second term here, don't forget the negative sign, and it's always to this term, power of this term. So once you have written this, you do some math, you simplify, and you get this rather interesting answer. So don't forget your negative. So since this is a negative number to an odd power, your final answer is going to be negative. Okay. So those are some quick examples of how to use the binomial theorem to expand binomials. Thank you for listening.